All right, so yesterday I introduced you to something that I like to take 2 days to work with because it looks weird, but it's actually not. We talked about point slope form. And it has everything in it that you already know. Y's, x's, and a slope, right? We already know what those things are. We already know that anytime you see a y and an x, you can put coordinates in for there. You already know what a slope is. And we talked about why these points are the starting point, right? So I asked you to look at, we did two easy ones that followed the formula exactly. Then there's 4 here that do a little weird, couple of weird things, right? So, and I asked you to use your brains to try and figure these ones out. So, number 3, what is the starting point? -2 and -1. Why? Because you need to use the opposites because they need to be equal, right? If I put -1 in for y, -1 plus 1 is 0. And if I put -2 in for x, -2 plus 2 is 0. So 0 equals 0. So that's why I can start at that point. That's why it works. If you can't remember why it works, all you have to do is remember it's the opposite sign. Okay? Now, what then is the slope here? This is where it gets tricky. 1. Because if there were brackets there, the slope would live right there, wouldn't it? And what's the number that we never write? 1, because the slope just multiplies by this bracket set, doesn't it? But 1 times x plus 2 would just be x plus 2, wouldn't it? All right, good. Look at the next one. What's weird there? There's no number beside y. What number shows no number? 0. So what is the x value I start at? -4. And what is the y value I start at? 0. And that also should tip you off because when y is by itself, right? That's something we know. And what is our slope there? 1/2. Excellent. What about this one? What's our starting point? -5, -3, and what's our slope? -1. Nice. And then 6 is just back to a normal one, just to remind you of how easy this actually is. What is it? 1/10 with a slope of 4/5. Now, before we go on, I want to make a couple of points to you. 1, this can be used any time you know any point. Now, what do I mean by that? Any point on the graph will work in this form, even if it is an intercept that we can use in other forms. Does everybody understand what I am saying? As long as you have an x and a y, you can use this form. Any x and y. Everybody with me? All right. And the second thing I want to remind you of when we are doing this is you can sub y2 minus y1 over x2 minus x1 in for m. Because this gets us our slope, doesn't it? Right? And this is slope. So if I have 2 points, any 2 points on the graph, can I use this form? Yeah, because those 2 points will give me the slope that I can then put in for m. And since I have 2 points, do I have 2 x's and y's that I could put into the equation? Yes. Is everybody with me? All right, let's turn the page over and actually use this a little bit. The first two are exactly what you just did. You did it 6 times, so you shouldn't have any trouble with it. All you got to do is decide your starting point and your slope. So what in this first one is my starting point? -1, 2. And my slope? 2 over 3. Then all I do is I come over to the graph and I put my point on there. Now, up until now, we've known the intercepts, right? So our first points were always on one of the 2 axes, yes? The only difference now is it's not. So all I do is I go out to -1, down 2, and I put my dot. And instead of counting from an intercept, I just count from there. Sorry, yeah, it's up 2. Anyway, and I just count from there. And how do I count? The exact same way I counted when I was doing slope-intercept form. How do I do a slope of positive 2/3? Up 2 and 3 to the right. And then what should I do just to make sure? Down 2 and 1, 2, 3 to the left. Then I can connect the dots. Is everybody cool? It's easy to work with. The only tricky thing is that opposite thing, right? And like I said, you don't even need to know why that works. It's helpful to know why it works. But if all you remember is its opposites, then use that. Okay? All right, what's the next one? What's my starting point? And what's my slope? Which is really what? Then I graph it. -2 over 1 means down 2, right 1, or up 2, left 1. How far can I continue that? Forever. If you don't like drawing a line through only 3 points, you can make as many points as you need to make it easier for you to connect the dots. Also, if I ask for an intercept, you can always keep counting until you get there, if you're bad with algebra. Is everybody cool? Can everybody do the basics? All right. Now, as always, as soon as you guys all agree that you can do the basics, we got to start adding stuff. So let's add something. Read number 9 and tell me what in there is hints for what you need to do. I'm going to have a sip of coffee. I'll let you think about it. All right. What in there is a trigger word for math class? Perpendicular. We know something about the word perpendicular, yes? What else in there? There's another important... What? They cross on the y-axis. Which means if they cross on the y-axis, they must share something, right? What do they share? If 2 lines cross on the y-axis, then what do they share? The intercept, yes? So that's important. And thirdly, we know one of the lines is that. Right? Now, is that line in a form that we are comfortable with? Right now? No. Can we make that a form we are comfortable with? What should I do with line 1 right now, which is 2x minus y plus 8 equals 0? Okay, I'm going to move the y over to get 2x plus 8 equals y. Is that a form with which we are comfortable? It is, right? We could graph that in our sleep, can't we? Let's graph it. Where do I go? 1, 2, 3, 4, 5, 6, 7, 8. And then a slope of what? Positive 2. But I can't go positive 2 because that'll take me off the graph. So what's the only thing I can do? Negative 2 and negative 1. negative 2, negative 1, negative 2, negative 1. And I'm going to stop there because we don't care about that line, do we? We care about this other magical phantom line, line 2. What do we know about line 2? We have two very important pieces of information to line 2, don't we? What are they? I know line 2, the slope of line 2 is perpendicular to the slope of line 1. We know something about that. What else do we know about line 2? Line 2 has what y-intercept? Great. So, if this is line 1, and line 2 is perpendicular but shares the y-intercept, what is line 2's equation? We know we can write it as y equals mx plus b because we have a slope and we have a y-intercept, don't we? What is the y-intercept? 8, because we know they cross on the y-axis, don't we? What's the slope? What does a perpendicular slope mean? Flipped and reciprocated. Reciprocated and sign change. This guy's positive 2 over 1. How does he flip? Negative 1 half x. And that is line 2. Everybody cool? Now, you should be saying to yourself, Mr. Myers, why did you teach us point-slope form and then you went back to slope-intercept form? For a reason. We're all comfortable with slope-intercept form, aren't we? Now, watch. What is that point right there? What are its coordinates? 0, 8, correct? Everyone agree? And we know the slope of line 2 had to be negative 1 half, right? So if I take this and I put it into point slope form, y is 8, right? Y minus 8 equals m negative 1 half x minus 0, right? Everyone see it? Now, x minus 0 is what really? Negative 1 half x, yes? And then if I move that over, what do I get? Everybody see? It's the same line. So you can use any form you want. I'm going to show you even a third form. All three forms have their benefits. You got to use the one that works for you. Everybody cool? All right. That's actually where I am done. There's no new stuff. But this page, please notice how much stuff is on this page. This is one of those things where the concept is real easy, right? Change the sign, put the dot in the graph, count for slope. That's all we did, isn't it? But it applies to every single graph you could ever do. And it applies to real life graphs like finance, like money, like resource use, all kinds of things, as long as you have any point on the graph. Now, in math, all those points on the graph are what? They're coordinates. They're all xy, right? In real life, are they xy? What are they in real life? Think back to the previous unit. They represent something, an IV and a DV. Okay? So you're going to take x and y, but in these questions, you're going to apply them to real life situations. Understand? But the rules still work. Okay? So I'm going to cut this down a little because I know that when you guys see this much work, a great many of you really don't want to do it. 4, 5, and 6 are all pretty much the same thing. They're in your notes. Just do a couple of them. Actually, even 7. You just have to look at a few. Nine, I recommend you do all of. If it's 11, I recommend you do all of. Don't care too much about 12, you've already done it. Don't care too much about 13. Don't care too much about 14. And 16 to 23, I'd recommend you do 3 of them. Okay? That is significantly cut down. Right? Now, I've been trying all year to say to you guys, do a few questions till you know what you're doing. And what I've been getting is almost nobody doing anything. So I'll help you out now. I've cut it down for you to what I think I would do if I were you. All right? Those of you that want the A, there's a ton more questions here. Do them, practice it, get your A. If all you want to do is get out of here, what I just showed you to do, know it. All right? And it's only 8:40. That gives you 50 minutes to get this done. None of you should be taking any of this home. All right? But I do this particular form of the line, point slope form. I like to take a little bit of time with it because it is deceptive. It seems easy. Then you start using it, and it's a little harder. But then when you get used to it, it's your best friend in graphing. Because it just tells you what to do. Pick any point on the line, anywhere, and you can put it into the equation. Everybody good? All right, go. I will be walking around and helping once I take attendance.